Good afternoon, class. This video is, the purpose of this video is to review what we learned so far in our vector unit. I know there's been a lot of interruptions. I want to make sure we're all on the same page and moving forward, and also to teach one new lesson, okay? Part of this video, like I said, is I'm going to be reviewing, go over your homework from Tuesday, February the 20th, and go on to another lesson. So please make sure you watch the entire video. Let this focus in. Focus in. Remember, vectors have, focus. Maybe it will focus in just a minute, guys. I'm sorry. Vectors have both magnitude and direction. You need to know that, okay? An example of a vector is, I walk 35 paces due north. It has the magnitude of 35 and the direction of north. Okay, the first thing we're going to look at, I'm sorry, it's so blurry. Hopefully it will clear up in a minute. Okay, so in your homework, it says find the following vectors geometrically. 3a plus b. We want to find that geometrically. Remember, when you're finding those geometrically, that involves drawing them, okay? Drawing them. We can perform operations with vectors two ways, geometrically and algebraically. These are algebraically here. So let's look at 1 through 4. 1 through 4. Alright? Now, we're using the A, B, and C that we did in class today, okay? 3A plus B. I hope you have some chart paper. Graph paper. That's what you need for this. So I'm going to use the same thing we did in class today, okay? I'm going to use the same little area over here. So the first thing I'm going to do is 3A plus B, okay? If we look at A from the day, you went down 3 and right 3. Since it's 3 times this vector A, that means I'm going down 9 and right 9. So let's look here. I'm going to start here. Go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I barely got that right there. Yes. So I would draw that vector. And I will label that vector VA. Now I want to add B. Remember, B was right here. We changed B to A. Instead of get from the head, from the tail to the head, I went down 1 and left 3. Down 1, left 3. So when you add these geometrically, you start at the head of the first. So I'm going to go down 1 over 1, 2, 3. Okay? So this is your given vector. First of all, you figure out this is a vector. What did I do to go from the tail to the head? I went down 3, right 3. Well, since this was 3A, I followed the same direction. So I multiply both of these by 3. So I'm going down 9 over 9. Plus B, start at the head of the first one. Now B is over here. We didn't use this one though. We used this for B. I made another one. Down 1, right 3. Down 1, right 3. Now your answer, make sure you label this, is called the resultant. And the way you draw the resultant is from the tail of the first one to the head of the second one. Tail of the first one to the head of the second one. And that represents 3 vector A plus B. That is the sum of the two. And that would be number 1. Okay? Number 2 is A minus B. A minus B. Okay? So A stays the same. I'm going to start right here. I'm going to go down 3, 1, 2, 3, right 3, 1, 2, 3. That is vector A minus B. Minus B. Now remember, a minus in math means opposite. So this is the B, original B. Instead of going down 1, I'm going to go up 1. And instead of going left 3, I'm going to go right 3. 1, 2, I'm going to come off the page. So that's negative B. So B was originally down 1, so I'm going to go up 1. Instead of going left, I'm going right 3. And that's vector A minus vector B. Number 2. Number 3, A minus 2B. A minus 2B. I'm going to run out of room. Okay. I'm going to start up here somewhere. This is number 3. A minus 2B. So A is originally down 3, 1, 2, 3 over 1, 2, 3. Now it says minus 2B. It means you're going the opposite direction and you're going to times it by 2. So normally we go down 1, we're going to go up 2. 1, 2. Instead of going left 3, we're going right 6. 1, 2, 3, 4, 5, 6. The resultant, okay, first I'm going to label this vector A. This is negative 2B. Your resultant is from the tail of the first one to the head of the second one. That's going to be A minus 2B. And the final one, 4A. When you just got 4A, you're going to draw one vector. Now I want you to go back before we do number 4. Remember, this is the resultant. That's the answer is represented by that final vector you draw right there. Now number 4 says 4A. So I go to A, instead of going down 3, I'll go down 12 and left 12. I don't have room to draw that, but that's how you would do that. Down 12, left 12. You can draw that one now. Alright, so that is how you do numbers 1 through 4. Alright, let's look at 6 through 18. You want to look at this one? And this covers everything that we've learned so far. Alright, number 6. We want to write the vector in component form. Remember, component form is x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. That gives you the A and the B component, okay? So on number 6, look at number 6. They give you the A is negative 8, 6, and B is negative 2, 3. And we want to find the vector component. X sub 2 is negative 2 minus a negative 8, comma, 3 minus 6. That's a double negative. Six, negative 3. Now we're going to find the magnitude. Your A is 6, your B is negative 3. Square root of 45 is 3 square root of 5. You break that down. So you found your component form. They want you to find it. That's the actual length of the vector. This tells you if you were to draw a triangle, your horizontal component will be 6, your vertical will be 3. Let's look at number 8. We have vector A, negative 4, 7, and vector B, negative 1, 5. Let's find the component form. Negative 1 minus the negative 4. 5 minus 7. Double negative. That gives me 3. That gives me negative 2. Now I'm ready to find my magnitude. Remember the magnitude formula is square root of a squared plus b squared. You got to know all those formulas by heart. 3 squared plus negative 2 squared is 9 plus 4, which is the square root of 13. Remember, vectors have both magnitude and direction. This is the magnitude. That's the length of the vector. If I was to draw that vector out, there's my length. That is my length, is the magnitude. Magnitude. If you were to make a right triangle, the horizontal and the vertical component is represented by the component form. Alright? Let's look at the next part, subdirection. It says, let vector v be negative 1, 3, w be 2, negative 5, and u equal 2, 4. Find each vector, or scalar. Okay, first of all, your performing operations with vectors, these are easy. Now, the vectors are in component form, therefore your answers will be in component, okay? So let's look at number 14. We have 3w plus 2v. 3 times vector w plus 2 times vector v. You can distribute the 3. Gives me 6 and negative 15. Distribute the 2. That gives me negative 2 and 6. Add your corresponding components. 6 and negative 2 is 4. Negative 15 and 6 is negative 9. So your answer will be 4, negative 9. Number 16, 3 times vector v minus 4 times vector w. 3 times v, which is negative 1, 3, minus 4 times vector w, which is 2, negative 5. Distribute. That gives me a negative 3. That gives me a 9. Distribute the negative 4. Now, if I'm going to distribute by this negative 4, that negative goes with it, so I'm just saying negative 4 times 2 is negative 8. Negative 4 times 5 is 20. Add the corresponding parts. That gives me negative 11. That gives me 29. Alright, number 18. Now this, you see there's magnitude signs in there. There's magnitude signs in there. So you have to do is inside the symbols first and then find the magnitude. So I'm going to say 2 times vector u, which gives me that. Now I'm going to use the magnitude formula. You have 80. Let's break 80 down. Pair of 2's, a pair of 2's. That gives me 4 square root of 5. That's my magnitude. That's the actual length. You need to stop and pause the video now. Would be a good time to review. Now remember, this is component form. We're about to talk about another form called linear combination. Linear combination. And that is in the form AI plus BJ. Okay? Remember, component form is A, comma B. These two mean the same. Let's say we have this. That means the same. 4i minus 5j, 4, negative 5. That's your horizontal component and your vertical component. It means the same. It's just written two different ways. Alright, let's look at number 28. It says, write the vector v in the form AI plus bj, given its magnitude and the angle alpha makes with the position. So here, guys, you're given the magnitude and you're given the angle. Magnitude and angle. You want to write something in linear combination. Well, if you want something in linear combination, you got to know the A and you got to know the B. So these are the two formulas you got to know. A equals magnitude times cosine of theta, and B equals magnitude times sine of theta. So on 28, they tell you that the magnitude is 8 and your angle is 45. Cosine of 45 is square root of 2 over 2. I can cross simplify here because there's no plus, so that leaves me a 4. A equals 4 square root of 2. B equals 8 times sine of 45. Now I'm ready to write it in linear combination. 4 square root of 2i minus 4 square root of 2j. These both happen to be the same. Number 30. We're going to find the A and B again. A equals the magnitude. The magnitude is 10. My angle is 3/30. So 10 times the cosine of 330. B is going to be 10 times the sine of 330. A equals 10 times the square. Okay, so cosine 330 is in 4 quadrants. Be positive. The reference angle is 30. It's square root of 3 over 2. These cancel out, leaving 5 square root of 3. B equals 10 times the sine of 330. It's negative 1/2. B equals negative 5. So your linear combination would be that. Note that I wrote it in component. Now you want to do this, but remember, this means the same thing if I told you to write in component. Make sure that you know that reading them either way, that is your horizontal and vertical component, okay? But it didn't ask you for this, it just asked you for that. Alright? Let's say 2 other problems here. We had to look at a picture. I'm going to draw this picture better so you can see what's going on here. Actually, I think it was like this. The error is right there. I'm sorry. This is a dot down here, error here. Okay. So it says A plus B equals E. Well, if that was true, wouldn't E need to be drawn to? Okay, A plus B. That's right. Tail to head, from tail to head. So that we drew that correct. But if E was correct, it should have started the tail of the first one to the head of the second one. So that is false, but to make it true, we could say negative E because it's drawn backwards. So you could put A plus B equals negative E. Now, the 32, D plus A plus B plus C equals E. Well, in this case, it has to start at D and come back at where it started from. So let's go here. D plus A plus B plus C. Yes, that is true. Okay. Now, let's go back to our note taker page 2 and I finish up this diagram. That was confusing some of us today. Alright. We're going to see if it's true or false. Now let's go back to 20. A plus B equals F. Let's review. A plus B equals E. Well, for this to become true, A plus B, then E should be drawn from the tail of the first one to the head of the second. That's why that's true. Here it says D minus E. When it says minus E in a drawing, it means it's drawn backwards, okay? So here we go. D minus E, that is drawn backwards, plus F equals C. Well, this point is all the way right here, but if this is the starting point, this end, shouldn't C be backwards? Should it be going from here to here? So that is false. It will be D minus E plus F equals negative C. Let's get 22, we're going to go 23. This is another one. If it's 0, it's going to start point and end back up there. A plus B plus K plus G. It starts right back here, so that's true. 24. K plus G, that's correct, equals F. Well, if it would equal F, it means it should be going from start here and put here, but since it isn't, it's false, and that's why you put this equal to negative. It's drawn backwards. Number 25, G plus H plus E equals D. Let's see how that goes. G plus H, well, H is way over here, so you know that's false, so we need to rewrite. H plus G plus E equals D, because D is the final from the start of the first one to the end of the second one. Let's look at 26. A plus B plus C plus H plus G equals 0. Yes, that's true. Started here, came back here. 27. K plus H equals C. Well, C is drawn correct from the start of this one here. But which one's drawn backwards? H. So that's false. You could correct it by saying K minus H equals C, because that's drawn backwards there. Remember, negative means opposite in math. Alright, now I want you to turn to page 3 in your note taker. Page 3 in your note taker. Okay, I'm going to give every time you get number 3. Alright, we talked about that in vectors you can add, subtract, multiply, so far. But you do not do division of vectors. That's the one operation that they do not have. But they do have a fourth operation that's just exclusive to vectors, and that's called the dot product. So it's not division, it's called the dot product. And this is how they tell you the dot product here. The dot product of this vector and this vector is defined as this. And this is just what this means. You take your x component here, multiply it by the other x component, add, then say this y component times this y component, and you get a single answer. It is read as A dot B. So if I want to find the dot product of U and V, U dot V, this is how I do it. Multiply negative 3 times 3. Plus 4 times 6. That gives me negative 9 plus 24, and that is 15. That is my answer. That's the dot product. Here I'm going to find 2 times negative 14 is negative 28, plus 7 times 4, which is 28. Negative 28 plus 28 is 0. That is my dot product. That's as easy as it goes. Now, two vectors with a dot product of 0 said to be orthogonal. You need to know that definition. Orthogonal. Okay, orthogonal means the vectors are perpendicular. That means they meet at a right angle. They are perpendicular. If you get a dot product of 0 like this, that means they are orthogonal. They are perpendicular. So it says find the dot product, U dot V. 3 times negative 5 is negative 15. Negative 2 times 1 is negative 2. That gives me negative 17. Are they orthogonal? No. Over here, negative 2 times 9 is negative 18. Negative 3 times negative 6 is positive 18. That gives me 0. Are they orthogonal? Yes. That means they meet at right angles. So, I went over your homework for Wednesday night. For Tuesday night. I'm sorry, I went over your homework for Tuesday night. I did this example. Now, this is your homework that's going to be due Thursday. It is page 11. Numbers 5 through 29 odd. Now, so Mr. Minister, what if you asked me to find the dot product of something like this? Alright, well you still multiply the first one. 8 times negative 1, 8 times negative 1, and then 6 times 2. It gives me negative 8 plus 12, which is 4. That would be the dot, that would be the dot product there, and that would not be orthogonal. So even if it's linear combination, you still multiply your I terms and then your J terms and add them together. Okay? Alright, so make sure you have this homework due on Thursday. Thank you.